In this lesson, we will look at two examples of matching the equation of a parabola to the correct graph. Our first equation is y equals 5 times the square of x plus 1 minus 2. Our textbook refers to this as the standard form for the equation of a parabola. Some other sources refer to this as the vertex form for the equation of a parabola. Because the x part is being squared, notice the equation fits the form of y equals a times the square of x minus h plus k. When we have the equation of a parabola in this form, the axis of symmetry is vertical, meaning the parabola opens up or down. If a is greater than 0, the parabola opens up. If a is less than 0, the parabola opens down. And the vertex is the point h comma k. Looking at our equation, notice a is equal to 5, and therefore the parabola opens up and looks something like this, where we have a vertical axis of symmetry. And now let's also determine the vertex from the equation. Again, the vertex is h comma k. Notice in our notes, inside the parentheses, we have x minus h, and our equation has x plus 1. You need to recognize this indicates that h is negative 1 because x plus 1 is equivalent to x minus negative 1. Because h is negative 1, we now know the x-coordinate of the vertex is negative 1. And notice in the notes we have plus k on the end, and we have minus 2, which indicates k equals negative 2. The y-coordinate of the vertex is negative 2. And now let's see if we can narrow down our choices. All the parabolas open up, and therefore let's identify the parabolas that have a vertex of negative 1 comma negative 2. In the first row, the last parabola has a vertex of negative 1 comma negative 2. Then looking at the second row, the last graph also has a vertex of negative 1 comma negative 2. One way to determine which graph is correct is to look at the absolute value of a. If the absolute value of a is greater than 1, the graph is vertically stretched and will appear more narrow. If the absolute value of a is between 0 and 1, the parabola is vertically compressed and appears more wide. Remember, the value of a is 5, the absolute value of 5 is 5, and therefore the parabola we're looking for has been vertically stretched by a factor of 5 and is more narrow, which indicates the parabola in the top row is the correct graph. Another way to verify this is the correct graph would be to find the intercepts. Let's also determine the y-intercept from the equation. Remember, to find the y-intercept of a graph from the equation, we set x equal to 0 and solve for y. Substituting 0 for x in the equation, we have y equals 5 times the square of 0 plus 1, or the square of 1, minus 2. Simplifying, we have y equals 5 minus 2, or 3. The y-intercept is the point 0 comma 3. And notice the y-intercept of the parabola in the top row does have a y-intercept of 0 comma 3, and the parabola below does not. Once again, verifying this is the correct graph for the given equation. Let's take a look at a second example. Now we have y equals negative 1/5 times the square of x minus 1 minus 2. Once again, notice the equation does fit the form of y equals a times the square of x minus h plus k. This time notice a is negative 1/5. Because a is negative, the parabola will now open down, but still has a vertical axis of symmetry. And now let's determine the vertex, which again is h comma k, from the equation. Looking at our equation, inside the parentheses we have x minus 1, which indicates h is positive 1. And because we have a minus 2 on the end, k is negative 2. This indicates the vertex is 1 comma negative 2. Let's narrow down our search by first determining which parabolas open down and have a vertex of 1 comma negative 2. Well, notice the first parabola has a vertex of 1 comma negative 2. All the parabolas open down. And the last parabola in the first row also has a vertex of 1 comma negative 2. None of the parabolas in the second row have a vertex of 1 comma negative 2, and therefore either the first parabola or last parabola in the first row are the correct graph for the given equation. Again, there's a couple of ways we can do this. If we consider the absolute value of a, notice the absolute value of a, or the absolute value of negative 1/5 is 1/5, and because 1/5 is between 0 and 1, the parabola has been vertically compressed, which makes the graph more wide, which indicates the last parabola in the first row is the correct graph. But again, let's also verify this by determining the intercepts, or more specifically, let's just determine the vertical or y-intercept. So again, to find the y-intercept, we set x equal to 0 and solve for y. Subbing in 0 for x in our equation, we have y equals -1/5 times the square of 0 minus 1, or the square of -1, minus 2. The square of -1 is 1. -1/5 times 1 is -1/5. Y is equal to -1/5 minus 2, or minus 2 over 1. To subtract, notice the common denominator is 5. -1/5 minus 10/5 is -11/5, which is a decimal, is -2.2. Using a decimal value might be a little bit easier to recognize on the graph. And notice the last parabola in row 1 does have a y-intercept of 0, -2.2. And therefore this is the correct graph for the given equation. I hope you found this helpful.